be talking about functions, what makes something a function. I'm going to show you guys today, I'm going to go through some definitions of the different parts of a function. So like domain, range, we'll make a list of our domain and range. And then one of the biggest things on here is determining whether something I give you is a function or not. So I'm going to show you two different ways to figure out if something's a function. Right off the bat, they give you this definition, the term that says a relation is a function provided there's exactly one output for each input. And it is not a function if one input has more than one output. Bathroom. Okay, so everybody take a look down here at the bottom. It says in order for, and we really just call it a relation, in order for it to be a function, every input must have an output. Okay, so all of our inputs are the x values, so every x that we plug in has to have only one distinct output. Okay, two different inputs can have the same output. So make sure you guys listen to what that just said. Two different inputs, so I could have an x of 4 and an x of 5. The two different inputs could have the same output, like 7. That would be okay. One input can have only one output. So what would not be okay is for you guys to see this. If you see 3, 4, and then you see 3, 5, this right here would not be a function. Because then what that means is, if you plug the number 3 in, how many answers are you getting? You're getting two different answers. You're not allowed to get two different answers if you just plug one number in. So up here, I plugged in two different answers. Now they are two different numbers and they gave me the same answer, but that's fine. It's all about those x values. It's all about the inputs. If you have the same input getting two different outputs, it makes it not a function. Okay, this one up here, this one would be okay. This one would be a function, whereas the other one is not. And notice it says all of your inputs are also called your domain. So all of your x values make up your domain, and all of your outputs, which are your y values, make up your range. So if I ask you guys today to list out your domain, you are just going to make a list of all the x values. If I ask you to list out your range, you're going to list out all the y values. Okay, now I will ask you to put them in order least to greatest, and then so you might have to shuffle some things around. And if a number is repeated, you don't have to list it more than once. You can just list it one time. Okay, go ahead and turn the page. So here's an example that says, which of the following relations are functions? So what I would do is I would look at, and I don't know if you guys are going to be able to see this or not, but I would look at the x values first. So all the ones that I'm circling, I have a 9, a -5, a 2, and a 3. Are they all different? Okay, as long as all of your x values are different, it's automatically a function. So R so far is good. Now let's look at S. There's a 6 here and a 6 here. So what you have to do then is, since you see an x that repeats, check the corresponding y value. If these two happen to be the same, then they're trying to trick you. They're trying to give you the same ordered pair twice. And if they were the same, it would be okay, because the number 6 would only have one output. But this 6 gives you an output of A, and this 6 gives you an output of B. Is that okay for a function? Would that be a function, yes or no? That would not be a function, because the input of 6 has 2 different outputs. So S is a no. I guess I could write yes and no. What do you guys think about T? Do you think T is a function, yes or no? Okay, I've heard both answers. So those of you that are saying no, why not? The Z's? The Z's, so look, here's a Z and here's a Z. This one has an answer of 7, this one has an answer of 0. Is that allowed? It's not allowed. So T would be a no. So it says no two ordered pairs can have the same first coordinate and different second coordinate. So they can have the same, or they cannot have the same X if their Y's are different from each other. And like I said, every once in a while they might throw in an ordered pair twice just to see if you're paying attention. Some people just look at their X's, and as soon as they see Z on there more than once, they automatically say, oh no, it's not a function. And I'm like, well, you've got to double check and make sure that their Y's are actually different. Because if their Y's were the same, they've just given you the same ordered pair twice, and that's okay. All right, down here at the bottom. I don't know what happened when this printed. And unfortunately, this is really dark, so I'm not sure you guys can even fill this in. But this number right here, this 3, is actually supposed to be over in this box. And you guys can't even see that. That's okay. You can see the arrow going through it, so it's not a big deal. If I asked you guys right now to list out the ordered pairs, this is called a mapping diagram. I want you guys over in this margin to write out our ordered pairs. The first column, these are the X values. So all we're going to do is we're going to list out -3, 1, 3, and 4. They're all of our X's. Now the arrow that is drawn will point to the Y value. So the arrow for -3 points to what number? The 3. The arrow that goes through the 1 points to a 1. Now look, see this right here, this 3? Notice that arrow also goes to the same number as the one above it. So it also goes to a 1. And then what about the 4? Goes to the -2. Normally these numbers right here would be inside this box. Like I said, I don't know what happened when it printed, but everything shifted over a spot. So, but that's okay. We can still work with it. If these are ordered pairs, and I said to you, I want you to list out the domain, this is what you would do. I know it's already on the paper, but this is how you would do it. Write the word domain. And all you're going to do is you're going to list all the different X values. So these numbers in the first box, list them in order least to greatest. So what's the smallest one? -3, and then 1, 3, and 4. That's all you have to do. Now I've never made students, especially in Algebra 1A, draw these brackets. They're a little bit harder to draw. This is called like set notation. I am using that quite a bit in Algebra 2. I'm not really worried about you guys drawing those brackets now, but just understand that, you know, you guys are probably going to see your answers written with those brackets around it, and that just means those are just all the different X values. Okay, it's just the set of X values that make up the domain. And then for range, you would do the same thing, but this time we're going to just list out our Y values. So the Y values come from technically this box, but they're over here in this column instead. But put these numbers in order least to greatest for me. What's the smallest one? The -2. And then 1 and 3. So like I said, sometimes you're going to actually have to shuffle these numbers around. They're not always going to be given to you least to greatest. So just make sure when you guys write them, you put them least to greatest. Okay, so then if I asked you, is this a function? Look at your ordered pairs. Do any of our x values repeat? Do you see any of those twice? No? So automatically we know it's a function. So right here they wrote function. They asked if it was a question. They said yes because each x value is mapped onto exactly just one y value. So each input has just one output. Okay? So anytime you're asked if it's a function or not, make sure you guys start by looking just at the x values. And as long as they're all different, you can automatically say yes. Are we okay? Everybody okay? All right, then you guys can turn the page. Make sure you're writing these down. And then again, I don't know, just ended up there in the middle. But what I'd like you guys to do is kind of do what we did on the last problem. If you guys could go out into the margin, and we're going to write our ordered pairs. So if we take this -3, what does it map to? What number? +3? Good. How about the 1? Goes to the -2. Okay, now that 1 has another arrow. So the 1 also goes with the 1. And then what about the 4? The 4 would go to, this 4 should be down here, so the 4. Okay, so list out your ordered pairs. Input will always be on the left, output will always be on the right. It's always x comma y. Now they've already done the domain for us, but I want you guys to remember your domain is just the list of x values in order least to greatest. So these 3 numbers given to us were already least to greatest, so they just wrote -3, comma 1, comma 4. Excuse me. And then the range are all these numbers that technically should be in this box over here. So it'd be 3, -2, 1, and 4. Now are those in order least to greatest? No, I don't even know why they wrote that. We're gonna move it around. We're gonna put our range down here. Because technically, sure, they listed them all out, but they really are supposed to be put in order least to greatest. So what number would I put first in my list? The -2. And then 1, 3, 4. And I'm gonna draw the set notation. All right, so then if I asked you, is this a function or not? Again, look over here where we wrote our ordered pairs. Do you see any x's that are on there more than once? Which one? Okay, so circle the 1, because that's the one that's repeating. Now, like I said, you cannot, without looking at the y's, you cannot right now say, well, no, it's not a function because the number 1's on there twice. You have to make sure that the y values are not the same, because they could try to, like I said, they could try to sneak it in there where they give you the same ordered pair twice and it would be fine. They're just trying to make sure you guys actually pay attention to this input has an output of -2, and if we have the same input again, it should not have a different output, but this one does. So is this one a function? Okay, so not a function. And you have to be specific when you tell me the reason why. You cannot just say it's not a function because the x value of 1 is on there twice. You have to say that the input of 1 is mapped to both -2 and 1. What I usually say, and I'm going to write it out here, I usually say my input of 1 has 2 different outputs. The input of 1 has 2 different outputs. Therefore, it's not a function. So what I'd like you guys to do is down at the bottom, I'd like you to figure out, you decide, and you can just write it over here in the margin. Either put yes or no for each one of those, basing it on whether you think it's a function or not. So again, just look at the x values first. So everybody should be looking at the first number in each ordered pair. That's where you should all be starting. See what you guys come up with, and then we're going to check and make sure that everybody had the right answers. All you have to do is put yes or no. Put yes or no based on whether you think it's one or not. Look at your X's. If your X's do not repeat, you guys should be putting yes. If they repeat, look at your Y's to figure out. I think you have it backwards. Remember, if they don't repeat, it's a yes. Yeah. If they don't repeat, it's automatically a yes. I mean, it did look like a lot of you had the right answers. What did you guys say for the first one? Yes. The second one? No. And then the third one. Okay. So the only thing I want to point out, a lot of times on a test or a quiz, they're going to ask you this first. They're going to say, is it a function? Yes or no. But then you have to give the reason why. So why would you say yes for this one? None of the x's repeat, right? That would be the same thing for the third one. You could say yes, none of the x's repeat. On number 2, when you say no, you can't just say one of the x's repeats. You have to tell me which x repeats. So which one repeated? The 1. So I said the 1 has 2 different outputs. If I were you, I'd write that down, because like I said, you're going to have to give me a reason why when it comes time for your quiz, which might be this Thursday. I'm not sure. It might be Monday. But it's coming up. We're going to just do mostly functions this week, and then I think the quiz happens pretty quickly. Anywhere you have a yes, you guys can just put no x's repeat. No x's repeat. Those are usually just, I mean, those are the 2 answers that you'll always put. It's either yes because none of the x's repeat, or no because, and then tell me which one repeats and that it has 2 different outputs. All right, go ahead, turn the page as soon as you're ready. All right, there is one other way to check to see if something's a function or not. So if I don't give you ordered pairs and I give you a graph, there has to be some other way for us to check to see if this is a function. This one's really not bad. So if you ever see me abbreviate it, if you see the abbreviation VLT, this is what we call the vertical line test. So everybody knows, look up here please. Vertical lines go this way. Vertical, straight up and down. What we're going to do is on every graph that I give you, we're going to draw some vertical lines. If that vertical line only goes through one point at a time, it's fine. But if you draw a vertical line and it crosses the graph like here and down here, that's a problem. That means it has the same x value twice, which we know is not allowed. Okay? So it says, if it is possible for a vertical line to intersect a graph at more than one point, it is not a function. Okay? If it only goes through one point at a time, we're good. If it goes through more than one, we're going to say no. All right? Pick up those pencils. You guys are going to draw some vertical lines here. So look down here. If I were to draw, so go ahead and draw a vertical line through that first ordered pair you see. How many points did it go through? Just one. So that's okay, right? What about here? What'd you say? So if I draw this vertical line, how many points does it go through? Okay. Is that allowed for a function? No. So you guys can see right here, they already wrote, is it a function? And they said no, because 2 points are on the same vertical line. You guys will see the vertical line test again. Well, it used to be in the Algebra 2 curriculum. I'm honestly not sure if it is anymore. It might just be here in 1A. So if I give you a picture, if I give you a graph, all you guys have to do is draw some vertical lines. And if it passes through more than 1 point, you know it's not a function. So these two were fine. It really was just right here that caused the problem. So no, because 2 points are on the same vertical line. Okay, flip it over. I want you guys to draw the vertical lines through the points that you see. So right here, how many points does that go through? 1, so that one's okay. How about here? That one's okay. That one's good. And then that last one just goes through 1 point, right? So everywhere we drew a vertical line, it went through 1 point at a time, right? So is it a function? Yes. So is it a function? The answer is yes, because no 2 points are on the same vertical line. On the next, I don't know, I think there's 4 graphs that we're going to look at next. So I'm just going to show you some graphs, and we're going to talk about whether it's a function or not, based on drawing vertical lines. Are you guys all ready?
Yeah.
All right. Now the answers are already here, but we still need to talk about why. Like, you guys obviously can see that the first 2 graphs that are drawn, they both say yes. Okay? However, if I just threw this graph on a quiz, you need to be able to look at this and say, well, I know it is because if we just start, I mean, you can draw a vertical line anywhere. Notice how the first vertical line I drew crossed 1 time, right? Because the graph that you guys are looking at is this one, this purple one that I'm drawing. This is the picture that was given. And our goal is to just sit here and draw some vertical lines. Will there ever be a vertical line that I draw that it's going to cross the purple twice? No. So this one is a function because, so write this down, write it down, pick up your pencil and write it. No 2 points fall on the same vertical line. So if you guys tell me yes on a graph, that should be your answer when I ask you why, because it's going to say is it and then explain. So yes it is, because there are no 2 points that fall on the same vertical line. And then same thing with number 2. So this one, it's not a straight line or anything. It's definitely a curvy kind of graph here. But anywhere you guys draw, so you guys pick some places. You don't have to draw like 12 vertical lines on this thing, but just draw some vertical lines. Mine are terrible. They're not really straight, but that's okay. Is there ever a time when one of those lines is going to cross the curves more than once? No. So again, this is a function because no 2 points fall on the same vertical line. No 2 points fall on the same vertical line. You'll even have to write this out today on your practice page. So when you guys are practicing, there are going to be some pictures and you're going to have to say yes or no and then tell me why. So is everybody good with those first two? Being able to see that the vertical line only crosses one at a time? Yeah. Cool. Okay. Turn the page. Now, in case you guys don't see this right here, this vertical line is actually the line, the graph that's been given to us. Well, if I draw a vertical line right there, isn't it going to cross everywhere? Okay, so could that one possibly be a function? No. And do you guys remember back to when we were talking about slope? Every line had a slope unless it was straight up and down. Remember we said it was undefined? It's because it's not a function. So now you guys are seeing why the vertical lines had an undefined slope. So this is no, and it would just be because at least 2 points fall on the same line. Write this down, please. At least 2 points fall on the same vertical line. And then the last picture. This section right here, this diagonal section, isn't that diagonal section okay? Like if I were to draw a vertical line through anywhere in the diagonal part, it would be fine, but what's the problem? This, yeah, the vertical part right here at the beginning and that vertical part right there at the end. So this one would be not a function. And it'd be the same reason. We would have at least 2 points falling on the same vertical line. All right, so this is what I'm going to do. I'm going to give you guys a practice page. The first page of your practice page, front and back, is everything we've done today. So they're going to give you some ordered pairs. They're going to ask you to list out your domain and range, just like we did back here. So you guys will be given sets of ordered pairs. You will list out your domain and range, and then they're going to ask you if it's a function or not. Okay? Then there will be some mapping ones, just like these, although I do think the numbers are in the box. But you'll do this same process. Make some ordered pairs. Write out your domain and range and tell me if it's a function or not. Then there will be some that are graphs, just like these here at the end. The second page of your practice page is review over things we've already done, like Some of the stuff you guys just tested on Thursday shows up on that review part of your practice page. Okay, so I'm going to pass that out, and I'm going to give you guys like probably 15 minutes to get the front and back of the first page done, so the new stuff, and then we're going to go through that, and then we'll focus on the review. Okay?